Okay, so let's just go over a couple of these, all right? Not the whole thing. Number one, what's the vertex? You always start with the vertex. That's the first thing you do. Yes, you always look at your h and your k, and obviously h, you're going to think opposite, which is -2, and the k value is 0. There is no number that's being added or subtracted at the very end. So that's the first thing you state. That's the first thing you graph. Everybody go to -2, 0, put a dot right there. After that, you're going to draw your axis of symmetry, which is a vertical line going right through, and I always do it a green dotted line on my videos, goes right through that vertex, and it will be the equation x equals the x value of your vertex, which happens to be -2. So that's the axis of symmetry equation. What's the pattern that we're going to use? Well, the pattern, because the a value is 1, it's the same exact pattern that we were using on the notes, which is 1, 1, 2, 4, 3, 9. 1, 1, 2, 4, 3, 9. These used to be coordinates on the parent graph. Now we're just going to use them as a pattern to produce the same exact width on the U-shaped curve from that vertex. Okay, so this is a +1 as the a value, so it is going to be opening up. And let's use the pattern. 1 over, 1 up. Let's put a dot right there. Let's go back to the vertex and go 2 over, 1, 2, 3, 4 up, and put a dot right there. And then if we go back to the vertex and go 3 over, 9 up, I'm going to be off the graph just by 1. So I might as well plot it. You don't have to, but since it's only off by 1, I want to plot it right there, 1 unit off. And of course, you use that axis of symmetry, that green dotted line, to reflect those lines to the other side. That way it makes it super easy to graph. And again, how do you reflect it? Just count. 1 unit, 1 unit. 2 units, 2 units. 3 units, 3 units, same level. So that's our parabola. Put some arrows on it. Go through those points carefully. Make sure those arrows are pointing to the ones that are off the graph. The domain, x equals all real numbers. Any parabola will always have the domain x equals all real numbers. It's like a free point if I ask you that. The range, it's either going to be above or below a certain value, and as you can see, this is at the y value of 0, and it is above. So how do we stay at 0 or above? You're going to say y is greater than or equal to 0. How about the X intercept? Where does it cross the x-axis? Oh, that touches the x-axis at -2 and at no other value. Here's the x-axis. It touches right here at -2. How about the y-intercept? Where does it cross the y? It crosses right here at 1, 2, 3, 4. So the y-intercept is 4. Now the transformation, this is just something I want you to start thinking about, and let's write it down here. What happened if you were to think of the original parent graph, which has the origin as the vertex as the origin? What happened to the original parent graph compared to this new one? It got shifted 2 units to the left. So I would like you to write that down on the transformation. Shift 2 to left. And that's about it. Let's try number 3 right here. What's a vertex?
-2, 3.
Think opposite on h, -2, take k for what it is, 3. Perfect, right? H, -2, k is 3. Think opposite on h, take k for what it is. Could somebody give me the equation to the axis of symmetry even before graphing it? X equals what? The -2, the x value of your vertex. Super easy. How about the pattern that we're going to use on this guy? What's the pattern? 1, 1, 2, 4, 3, 9. That's because the a value is 1, and we got that pattern from the original parent graph. How about the domain? And we haven't even seen this parabola yet. What's the domain on this thing? It's always going to be x equals all real numbers. So look at all that information that we already have from the parabola, even without seeing the parabola. It's pretty crazy, right? If you understand your a, your h, and your k, you could state a lot of information about a graph that you haven't even seen yet. Okay, so let's go to the coordinate -2, 3, -2 on the x, 1, 2, 3 on the y. There it is. That's my vertex, -2, 3. What's the next thing to do? Next thing to do is to draw your axis of symmetry right through it. And that axis of symmetry, we said it was the equation x equals -2, the x value of our vertex. And we are going to use the pattern 1, 1, 2, 4, 3, 9. But the thing is, am I going to be going 1 over, 1 up? Yes or no? No. Why not? Why not up? The A is negative, which means you're going to go 1 over, 1 down. All right. Now, some people like to change the outputs to negatives. I just say recognize whether it's opening up or down, and then use the pattern to travel in that direction. So 1 over, 1 down. Let's put a dot right there. And then go back to the vertex and go 2 over and 1, 2, 3, 4 down right there. Then go back to the vertex and go 3 over, 1, 2, 3, and 9 down. 1, 2, 3, 4, 5, 6, 7, 8, 9. I hope I counted that right. Did I? Okay, and now let's map it over to the other side of the axis of symmetry. A point right there, a point right there, and a point down there. I mean, seriously, this is a very difficult section, but it's really easy if you understand your A, your H, and your K. I mean, honestly, I graphed this thing without doing any math. I mean, imagine if I were to make an input-output table, if I plug in a 0 here, do that math, square it, add it, negative, it gets all confusing. If you know that the A value is positive or negative 1, you could use a pattern 1, 1, 2, 4, 3, 9, and then you could answer the rest once you have it. So what's the range of this guy? What's the range? Y is less than or equal to what? 3. Perfect. Okay, now right here on the X intercepts, this is weird. It doesn't cross the X axis at nice locations. So I don't want to be, just give me an estimate. So let's do this. Put a squiggly line. And we're going to say that this first one, it's not at negative 1. Let's say it's at negative 0.3. This is just an estimate. Negative 0.3. And where else does it cross? It crosses at negative 1, negative 2, negative 3. Not quite negative 4, so maybe like negative 3.7 or something like that. Negative 3.7. So these are approximations. Later on in the class, I want to be like, what's the specific value? And you'll be able to, we'll do that later. But right now, just an approximation. How about the y-intercept? Where does it cross the y-axis? At negative 1. And how about the transformation here? Everybody write this down quickly. It got reflected over x axis. That means that it opens down. And it got shifted, shift 2 to the left and 3 up. Thank you for your time. Again, the transformation that we want to describe is that it got reflected. The parent graph would normally open up here. It opened down. That's why it's opening down. So the first thing we say is that it got reflected over the x-axis, and then after it opens down, it got shifted 2 to the left and 3 up. So that's the complete description of the transformation from the parent graph to this new parabola. Opens down and shifted 2 to the left and 3 up. Check this out, guys. So in a previous class, in period 6, I believe I explained number 1 and number 3. Let's explain number 5 with you guys and continue. Let's continue with this video right here. So I already explained 1 and 3 with the previous class, period 6. Right here it's period 7. Let's jump and start with number 5. So what's the first thing we need is the vertex. What's the vertex according to that H and K value? Negative 3, negative 4. Perfect. If we go to negative 3 and negative 4, that gives us that coordinate. Now that's the first thing to do, find the vertex. The second thing to do is to draw your axis of symmetry. And that axis of symmetry, I always draw it as a dotted line going right through that vertex. And the equation of the axis of symmetry is x equals the x value of your vertex, which is negative 3. Now, what's the pattern that we're going to be using? What's the pattern? 1, 1, 2, 4, 3, 9. Okay? And that's because the A value is 1, which means that it's going to be exactly as wide as our parent graph of that U-shaped curve of the parabola. That's why we're doing 1, 1, 2, 4, 3, 9. So from this vertex, go 1 over, 1 up, and let's put a dot right there. Then go back to the vertex and go 2 over, 1, 2, 4 up, 1, 2, 3, 4, put a dot right there. Then go back to the vertex and go 3 over, 1, 2, 3, and then 9 up. 1, 2, 3, 4, 5, 6, 7, 8, 9. Put a dot right there. And of course, we're going to use that green dotted line, the axis of symmetry. We're going to use that to reflect the coordinates to the other side. We're going to draw our parabola. Put some arrows on it, and we're good. What's the domain? All real numbers. X equals, very important to state x equals. How about the range?
Y is
Greater than or equal to what? Negative 4, which is the y value of our vertex. It's nice to see that the axis of symmetry is really x equals the x value of our vertex, and the range, it's always going to be y is either above or below the y value of our vertex. Okay, now how about the x intercept? Where does it cross the x-axis? Here and here. What are these? Negative 5 and negative 1? Perfect. So we're going to put negative 5 and negative 1. And what about the y-intercepts? Where does it cross the y-axis? Looks like it crosses at 5, right? Up here at 5 only. And now, how about this? We have some added idea that I want you to start practicing. If you compare your parent graph has a vertex 0, 0, and it's that regular U-shaped curve that we got the pattern 1, 1, 2, 4, 3, 9 from. But if we compare that original one to this new one, what are the transformations? How does it change? It doesn't get wider or narrower. It doesn't open down. It's the same exact U-shaped curve, but what happens? It goes 3 to the left and 5 down, right? No, 4 down, my bad. 3 to the left and 4 down. So let's write that down. The transformation is it shifts 3 to the left and 4 down. Now we'll talk about transformations more seriously tomorrow. Right here we just want to practice thinking of what happens from the original parent graph to get to this new one. You know what? Let's jump around. Let's try number 4 or number 6. Pick one. 6. All right, so let's begin with the vertex. What's the vertex? Negative 4, 8. So let's go to negative 4, 8 on the graph. Negative 4, 8 is way up here, way on the edge. And yes, that is definitely the first thing to do, to state your vertex. What's the second thing to do? Axis of symmetry. And that is going to be the green dotted line going right through that vertex. And if I wanted the equation, it's going to be x equals the x value of your vertex. So x equals what? Negative 4. Perfect. Okay, let's move on to the third thing that we need is the pattern 1, 1, 2, 4, 3, 9. Okay, and from that vertex, we know that the a value is negative, so I'm not going to be going 1 over 1 up. It's actually 1 over 1 down. And we put a dot right there. And go back to the vertex, go 2 over 4 down, 1, 2, 3, 4. Put a dot right there. And go back to the vertex and go 3 over 1, 2, 3, and 9 down. So we have 8, 9 would be right here. Everybody with me? Of course, you guys could count more carefully. And also stop me if I make a mistake. Sometimes I plot these points wrong. But anyway, we're going to reflect them over to the other side of the axis of symmetry, which is going to put a point right there, and a point way over here. And whenever I reflect, I use the color blue on my videos, just like I always use the color green for the axis of symmetry. Try to stay color coordinated here. So here's my parabola. It's opening down. Arrows. I'm good. Now, what is the domain? How about the range?
Y is less than or equal to 8.
Perfect. What is the, here's an interesting one. What is the X intercepts? Now, since they're not perfect values, let's just give an approximation, okay? So let's put a little squiggly line saying that's an approximately, see here's 0, here's negative 1. So I'm saying like negative 1 point, what? Negative 1.1? That's a good approximation, negative 1.1. And which other value would it cross out? An approximation 1, 2, 3, 4, 5, 6, not quite 7. So what would be a good approximation right there? Not quite 7. Negative 6.9. So that's a good approximation. Later on, I'll be asking for specific values. Right here, just give me an idea of where it crosses. Now, here's another very interesting one. If I were to ask you for the y-intercept, that one's interesting. Does anybody know what the y-intercept is? Negative 8. And how did we get that? Because obviously from this graph, you don't see where it's going to cross the y-axis. So back in Algebra 1, I hope you guys remember, to find the x-intercept, you set y equal to 0. And to find the y-intercept, you must set x equal to 0. So if you were to go back to the original, and if you were to set x equal to 0, you'd get 0 plus 4, which is 4, and then 4 squared, which is 16, with the negative in front would be negative 16, and then negative 16 plus 8 is negative 8. So the y-intercept is really negative 8. It will cross down here. Pretty crazy, huh? But anyway, how about we describe the transformations from the original parent graph that started at the origin as a vertex and opened up. Well, first of all, it gets reflected over the x-axis. It opens down instead of up. But the math vocab that we want to use is reflected over x-axis. It reflects over the x-axis. So instead of opening up, it's going to open down. And then after that, we're going to shift the vertex 4 to the left and 8 up. So after that, we're going to say, then shift 4 to left and 8 up. So that's the actual verbal description of the transformation from the original parent graph, the original U-shaped curve that had the vertex 0, 0 and opened up. It got reflected over the x-axis, and then it got shifted 4 to the left and 8 up. That's the actual descriptions for the transformation. We'll worry more about transformations tomorrow. So I think this video is long enough. You guys could try those last 2 on your own and check the answers on the back.